I'm on day 9 of the 2018 year of Advent of Code. Right. Marble Mania. Why not Rust? Don't know, I've never tried Rust. I think Python is the best for these kinds of challenges. I think it's just kind of the quickest to code in. Like, I'm sure Rust is a good language too, but even if I learned Rust, I think I would still code faster in Python. Especially if there's anything to do with, like, I don't know, handling strings. Alright. Damn it, 1 second. Okay, let's begin. Marble Mania. You talk to the elves while you wait for your navigation system to initialize. To pass the time, they introduce you to their favorite marble game. The elves play this game by taking turns arranging the marbles in a circle according to very particular rules. Alright. The marbles are numbered starting with 0, increasing by 1. Okay, fine. First, the marble numbered 0 is placed in the circle. So the marbles are put into a circle. And then 0 is placed in the middle. Then each elf takes a turn placing the lowest numbered remaining marble into the circle. Between the marbles that are 1 and 2 marbles clockwise of the current marble. Oh, so you... Sorry, okay, so you start off with nothing on the table. Then you place marble 0. So... between the marbles that are 1 and 2 marbles clockwise of the current marble... Okay, so this only really matters when you have 3 marbles. So when you have 1, you just place it. When you have 2, you just place it arbitrarily. And for the third one, you also just place it arbitrarily because it doesn't matter where you place it, I guess. Well, it does, doesn't it? Because clockwise... Alright, well, we'll look at the example later. Okay. Fine. However, if the marble that is about to be placed has a number which is a multiple of 23, something entirely different happens. First, the current player keeps the marble they would have placed, adding it to their score. What? Okay. Also, I forgot to open the chat window. So if it's a multiple of 23, you just add it to your score. In addition, the marble 7 which is 7 marbles counterclockwise from the current marble, is removed from the circle and also added to the current player's score. Okay, it's a bit long-winded, but it's not overly complicated. The marble located immediately clockwise of the marble that was removed becomes the new current marble. Oh man, alright. Alright, so 0. We start with 0. So then 1 is just placed. And 1 becomes the current marble. So, okay, after 1, the rule applies. So, the current marble is 1. The marble that's 1 clockwise is 0. The one that's 2 clockwise is 1. So, the marble gets placed in between the two. So you get 0, 2, 1. Then you've got clockwise is to the right. Right. Okay, so now you got 1 and you got 0. So the next marble gets placed at 3. I see. The goal is to be the player with the highest score after the last marble is used up. We've got 435 players. Last marble is worth 71184 points. What? So the goal is to be the player with the highest score after the last marble is used up. Why does it say last marble is worth 71184 points? What does that mean? Oh, it's kind of a reverse thing. So we're still following these rules, but we don't know how many marbles there are. But if we reach this, if we get this many points for a marble, we know that's the finishing point. It's just a strange input. So that's when the game ends, and the last marble is used up. So they're always counting the last marble as being a multiple of 23. What? But I'm a bit confused. What is this last marble thing in the input? I still don't fully understand this. They didn't give us a last marble in the example. Okay, so the last marble is 25. But that's not worth any points because it's not a multiple of 23. So why would we be given... So the example doesn't fit the input form, because in this example, the last marble was worth 0 points, 25. But in these examples, they're saying... Oh, this is ambiguous. I don't know. Alright, well, we can still code it and see what happens. Fine. I don't like it when they give an example which doesn't match the input, because then this just leaves it ambiguous. What I think this input example would be 9 players, last marble is worth 0, which is silly because there's several different things that could... There were infinite possibilities for last marble being 0. I'm just gonna have to code it and see. See, even with these last marble things, there are still more than one possibilities. Like, you could have one turn where you get 1618 points. There could be a turn later on where someone gets 1618 points. It's ambiguous. There could be 2 ending points. Nothing's stopping there from being a second time where someone gets exactly that many points if a different marble is picked up. I just gotta code it and see. I don't understand this last marble nonsense. I think this was poorly worded. Alright, so... Alright, so we've got... N number of players equals... Let me... Okay, number of players... 435. Press equals. Last marble. So should I just call that ending score equals that? So if someone gets that many points, hang on, are these numbers divisible by 23? Maybe they mean that marble is worth so and so number of points. No, it's not divisible by 23. Doesn't make sense. Alright, fine. Just try it this way. So we're going to use a list for this. So we can say... So we want to keep scores equals 0 for n. So that's each player's score. We need to represent the circle. So we'll say circle equals that. Or in fact, 0 is placed there. Okay. Current. We need a current marble. That's going to point to the 0, which is current in our circle. That's the current marble. And then finally, we need to count for marble in. So we can use an infinite sequence here from iter tools import count. For marble in count, start from 1. Let me test this out. Yep, starts from 1. Okay. Okay, so the player will be marble minus 1% n. That's just a convenient way to know which player is playing. So we start with 0, player 0. They're going to place the marble. If marble percent 23 equals 0. So this is the if it's divisible by 23, we do the scoring thing. So scores player plus equal marble. So you get the points for the marble. The marble, 7 marbles counterclockwise from the current marble is removed from the circle. Okay. So to remove equals current minus 7% length of circle. So that's the one we need to remove. And when we remove it, whichever is next in the array will be the next clockwise one becomes the new current. Okay. So we do delete circle, so just, or how do we do this? Do circle dot remove. No, that's by index. That's delete circle 2 remove. Okay, fine, we'll just space these out. And then current equals the new 2 remove, but it might have been the last one on the list, so we just have to do percent length of circle just to make sure we don't end up in an invalid current. Okay. Oh, we have to also add the score. So scores player plus equal circle to remove. All right, so that's probably the easier section. That's handling the score if it's multiple of 23. Otherwise, we just insert it. So no, this is the easier one. So this one we just to insert equals, so it'd be current plus 2 basically. So the next one afterwards would be +1, current +1. The next one after that will be current +2. So the position to insert will be current +2. So it'll be current +2% length circle. Then we can just do circle.insert to insert marble. So it won't put 1 at the end here. It'll actually put 1 at the beginning, but it's equivalent. And then current equals the index that we just inserted at. Now, the one thing I need is to check if marble +2 remove is the ending score, then what? We're done. What is the final result we want? What is the winning elf score? So we don't need to mess around with the circle anymore. We just break out of this loop. And then we want print max of scores. I don't know about this. Let's try running. It might just get stuck in an infinite loop. Yeah. I don't understand this ending score. Why didn't they explain this? The last marble is worth... Hello, DRJ. Time to make a space heater. I stopped it just in time. The wording of this problem doesn't make any sense to me. So we've got this. So they don't tell us how many marbles you start with. It's an unknown number of marbles. They take it in turns placing a marble into the circle. And if the marble is a multiple of 23, they get points. And then the example they give goes like this. So they just insert marbles up to 22. Then 23 doesn't get inserted. Instead, that elf gets points. So elf 5 gets points on that turn. And then we go insert 24, and we insert 25. And that seems to be the end. So player 5 gets 23 points. And also 9 because of that weird rule. So he gets 32 points. And then they go and give us an input which doesn't match the example's format. So now they're saying the last marble is worth this many points. What does that mean? I don't understand this phrase here. Are they introducing a new rule? Like you get a bonus that many points for the last marble? That wouldn't make sense because we don't know how many marbles there are. So I assumed it meant they're telling us end the game as soon as someone gets that many points on one turn. But that... So 1618 is not divisible by 23. So so that's not the points you get for that marble alone. So they're talking about the sum. The points you get for the multiple of 23 plus the extra marble you remove on that turn. They're saying if you get 1618 points on one turn, then the game ends. That's how I've coded it, but it doesn't seem to terminate. We'll try the example then. 10 players, 1618 points. Why did I hardcode this? This is supposed to be ending score. Let's see what marbles we're getting to. I mean, it's just going on forever, isn't it? If marble is a multiple of 23, hello, Nomad. So let's try the example they've given, even though it doesn't match the input format. So they have given n equals 9. And they are fixing it at 25. Well, they don't say how many marbles there are. They just Alright, let's test this out then. So ending score doesn't matter. So we're going to force it to be 1 to 25. And then the final score is 32. That's correct. To the example. But what the heck is this last marble thing? Let's print the circle, see what it looks like. Do this after this. Marble plus 2 remove. Oh! Why did I... Oh, there's my mistake. Whoops. So, bonus score is going to be that. Now, we add on the bonus score. And we have to use that variable there, bonus score. Alright, let's test the example then. So we've got n equals 10. Ending score equals 1618. We want marbles to count forever. Run. Still goes on forever. Ten, 1618. But that's more correct now. If marble plus bonus score is 1618, we're saying, then we end. That's the way I'm interpreting the example. That will never happen because these numbers are too big. So 1618 n equals 10. N doesn't really matter anyway. It's not going to change the time it stops. It just changes who gets what score. 8317. Last marble is worth... Or maybe... Okay, this is terribly worded, but maybe... Play with the highest score after the last marble is used up. Oh, maybe by last, when they say last marble is worth so and so points, what they mean is that's just the ID number of that marble. I don't know why they phrase it like is worth so and so points. So maybe we're saying, okay, take this out. If marble is that number, break. Just worth that position. That's a terrible way to word it because most of those marbles will never get picked up, so you never actually get those points. But I guess that technically makes sense, but that's... Oh my god. That's such a weird way to word it because it's just so different to how they did the example because... Whatever. Okay. I could think of at least 3 different sensible interpretations of that sentence. This one works, but I think they could have removed ambiguity by making the example match the input format. Alright, fine. So... So if we want to do the full example, we've got n equals 435. Am I? Yeah, okay. And then change that to that. Four one two nine five nine. Correct. Okay, fine. Part 2. Amused by the speed of your answer, the elves are curious. What would the new winning elf score be if the number of the last marble were 100 times larger? Guessing just adding 2 zeros is not going to... I'm more impressed that the elves can apparently keep track of several thousand marbles at a time. I mean, they work for Santa. They probably deal with... I mean, they're dealing with warehouses full of presents for the whole of the world, so... I guess they're good at keeping track of numbers and inventory in general. 100 times larger. Well... Okay, we don't want to print that. So so this was... Let me just test this out. So if we add 0, 0 here, run it. It's unlikely to finish. What? It's not that big. It's 7 million. It's not that big. The problem, though, is this list is being rebuilt every time. So we're going to have to switch to using one of the most classic data structures, the linked list, which doesn't often come up in these algorithm puzzles, but I think this is one case where you need a linked list rather than an array. So doubly linked list even. Yeah, 7 million marbles is not a lot. We just need to not keep rebuilding this list every time. So, okay, stop. So we don't want circle to be an array. Every time you insert or remove from an array, you have to rebuild the whole array from scratch. We just want to basically have it like a ribbon. So when you're inserting something, you just cut the ribbon, put the thing in there, and stitch the before and after to that ribbon. The rest of the ribbon is untouched. So we want class linked list, define or should we just say a node within the linked list, define in itself. So given a piece of data, self.data equals data. We need to, so every node knows which one came before it and which one came after it. So self.before equals none. Self.after. Now let's use prev and next. Self.next equals none. So that's a standalone node. That's all we need for that. All right, so then we need a class linked list. So we need a self.current. So the list will have a current, which is pointing to the current. And that's going to be a node that we make up on the fly, which is node 0. And we're going to wrap it up. So we're going to say self.current.prev equals self.current. So it's pointing to itself backwards. And self.current.next equals self.current. And it's pointing to itself forwards. So get rid of that circle. Circle equals linked list. So now we've got circle with a current node. Now, there's two cases basically. We delete and we insert. We have to do these. So delete, let's think. All right, so to remove, so it's no longer, so to get the one that we want to remove, so to remove is dot current for in range 7 to remove equals to remove dot prev. All right, so we point this variable to the current, and then 7 times we take the previous one. So it's now pointing to the one that was 7 spaces before. Take that out. Bonus score equals to remove dot data. Okay. Now we need to handle removing from the circle. So current will just be to remove dot next, the one that's to the right of it after we remove it. Take this out. Current, no. Circle dot current will be that. So the new circle.current is updated to be that, and now we have to remove the to remove. So we have to say, so if you remove a thing from a linked list, you basically have to look at the thing to the left, look at the thing to the right, and make sure their prevs and nexts are pointing to each other. So the prev, so to remove dot prev, that's the thing to the left, dot next is now updated to be to remove dot next. And to remove dot next dot prev is now updated to be to remove dot prev. Nobody's pointing to remove anymore. So it's now just a floating node in nowhere. It's we could actually delete this node from memory altogether, but it's alright, we could just leave it floating. Alright, so that's deletion. Just leave some spaces here. Alright, then insertion is similar. So to insert equals circle dot current, and then for in range 2 to insert equals to the next. So we're now looking 2 spaces ahead. And that's where we want to insert. So we want to create a new node equals node with value marble. To insert. So now we need to update all the different prevs and nexts. So hang on. We need to know the two nodes either side of where we're going to insert it. So let's just rephrase this. Let's say the before is going to be circle.current.next, and the after is going to be circle.current.next.next. So we're going to insert between these two. Okay, that's a better way to do it. Don't do this. New node, we create a new node. Okay, we're not using that. Alright, so before.next is now this new node. After.prev is now this new node. New node.prev equals the before. New node.next equals the after. And now we just update circle.current. Okay, this is complicated, but normally you'd do all this logic within linked list itself. So you'd have an insert method and you'd have a remove method. I should have done that, but I've kind of done it in this outside of the inner workings of the linked list, which is bad practice, but whatever. We're only doing one delete and one insert. Circle.current equals new node, the one that we just inserted. All right, let's see if we get the same answer now. 412959. Correct, we get the same answer. That's looking good. Now just add 2 zeros. So now it's doing 7 million steps, but it's just doing a constant amount of work each time. So it shouldn't take that long. There we go. So we're doing constant work each time instead of linear work each time. So we would be rebuilding a list that's millions long each a million times. But yeah, that's should be right if the first answer was right. Correct. Oh, that's a good problem. That goes back to the very fundamentals of computer science that people forget. The linked list. Because even though linked list is kind of the first thing you learn, usually, it doesn't really come up in most applications. Normally you use arrays, which is what I started by using. Linked list is just one of those things you have to... You have more obscure examples which use linked lists. I mean, our computers are using linked lists all the time, but this is behind the scenes. This is kind of really low-level, obscure stuff. Normal algorithmic problems, you use arrays and sort the arrays and stuff like that. But you can't forget about linked lists. In fact, it is a popular interview question as well to do stuff with linked lists. Because this marble game is like... I can't really think of a real life example you would do which is similar to this marble game in a real life software application, but I guess, yeah, that's the point. It's not really... It does come up if you work with operating systems, like designing Linux distributions and stuff like that, because linked lists are used often with memory allocation. It's like the free space on your computer is a bunch of nodes, free nodes, all pointing to each other. And so if you want to store something, you would take a bunch of those free nodes from the linked list, cut them out of that linked list, put your memory there, but then you have to stitch up the linked list after you've done that. So your free memory is just a list of nodes all pointing to each other in one big circle. Or not really in a circle, but in a line. That way, whenever you need free memory, you can get it quickly because it's always the next thing on your list. You can just cut it off without having to rebuild an array. So that makes it quick to store or retrieve memory. Well, it's not quick to retrieve memory because you kind of have to look through the list of retrieve memory. But that's where caching comes in. The OS uses caching to maintain pointers to frequently used locations. So that's basically, I'm describing the LRU cache from first principles, which is a very popular interview question and a very good one too. It's basically keeping track of, say, the 10 most popular locations you've used in your operating system. But every time you do anything, whether you access stuff or store stuff, it maintains a frequency table not a frequency table. It updates the least recently used cache if needed. If you've used something more recently than anything that's currently in your cache, then it has to discard the oldest, put the new in, the new recently used, and so that way it's still keeping track of, say, the 10 most recently used things. So if you need to access those things quickly, you can just look up in the LRU cache. And if it's a thing you haven't used recently, then you have to do the slow approach of going through the linked list. But the LRU cache gives a quick access to the most frequently used. Sorry, not frequently used, recently used. You could do it differently. You could make it look up the most frequently used, but then you need to keep track of a frequency table. But that's another way of doing it. It's not an easy interview question, but I've seen it. I've seen interviews ask you to implement LRU cache from first principles. I mean, that code there looks simple, but I don't think that's the full thing. No, it is. Yeah, I guess it is simple if you're piggybacking off the inner workings of DQ, but I think some interview questions won't let you use DQ, which is kind of like a double-ended queue in Python. I think they want you to code DQ from scratch as well, which means you have to build a linked list to make DQ, which is just basically doubly linked list, as well as the cache part. But yeah, I went off on a tangent there, but that's just an example of one thing which comes up in operating systems, which uses linked lists. But in high-level programming, it doesn't come up much. You usually work with databases, which you want arrays for, and you want to sort them. And you want fast access to stuff which is in the middle of the database, which you can't do with a linked list. Okay, I need to go to the gym. That's one problem done. So, can have a sneak preview of 10. Something to do with positions of velocities. Okay, so it's like a physics problem. Physics simulation with points in space, maybe colliding with each other. Cool. All right. I'll try and get another problem done tomorrow. See you guys next time.